Good morning. We are from SVS Embedded. The project title name is Smart Building Environment Control and Monitoring System. In this project, we are using a lot of sensors. Those are called temperature, humidity, and carbon dioxide. Oxygen is not possible, it is not sensor. So temperature sensor LM35, humidity sensor, and MQ2 gas sensor by smoke sensor or carbon monoxide sensor. So in this project I was used 80 mega 16 microcontroller. It's an 8-bit microcontroller having of 8 internal ADC channels are available. So here this microcontroller is an 40-pin IC, total 4 port. Each port consists of an 8-pin, total 32 input output bi-directional pins. So first of all I was used in transformer. So you can use the adapter also. So it's an 12-volt adapter. So most probably it is available in your country. 12-volt adapter with 750 milliamp current or 500 milliamp current. These are all utilizing only 5-volt power supply. So that's why we are using an bridge rectifier and one filter capacitor, 1000 microfarad by 25 volt electrolytic capacitor. The main purpose of this capacitor is to eliminate the ripples of AC transformer. So here I am using an 7805 regulator. So most digital logic circuits and processors need 5 volts power supply. So that's why I was given the 5 volts regulator. And so after that I was used one LED. When the power is inserted, that it should be on. When the power is removed, it should be off. So I am inserting the power, that LED should be on. So this section is called as an power supply section. So in our project we are using an 80 mega 16 microcontroller. Why I was choose this controller means we have an ADC channels are available. These 3 sensors are the analog sensors. We are converting into the digital format. Those are connected to the ADC.0 temperature, ADC.1 is connected to the humidity, ADC.2 is connected to the MQ2 by carbon monoxide sensor, CO2 sensor. So here that port to A ADC, port to B we are connected to the SPI protocol of this is an programming socket. So here I was used in crystal 16 megahertz crystal. This is the heart of the circuit for the controller to run the internal program. So here I was used one switch. This switch is called the reset switch. When the program is stuck, we need to restart this. Here the port to C is connected to the 16x2 LCD display, and this is a character LCD display. So whatever the process is going on into the controller, that should be displayed onto the LCD. So I am restarting. So smart building environment control and monitoring system. So after that, first of all I was used the temperature, normal room temperature it is displaying. Humidity normal with respect to the temperature, the humidity also displays. Again after that CO2 I was used the sensors, it was going. So all are 8-bit microcontroller, it most probably it will giving the 0 to 255. So it is in the form of voltage levels. So you can directly see on the multimeter also. So here I am using an Max 232 IC level converter, voltage level stabilization purpose I was used. These are the capacitors or the level conversion voltages ICs, voltage conversion purpose. Max 232 is displaying the data onto the PC. So this cable is called as an RS232 cable. So I am connected to my PC. Okay, it's an RS232 cable. So by the way, this cable is not available in your country. So better to go for the USB to RS232 cable. I will show. So this is called an USB to RS232. Most of the students using the laptops. So must and should you have to connect here to the laptop. you are connected to the laptop. This is USB and this is called the RS232. It's a male connector. I am giving the female. So you can insert this, you can get the data onto the hyper terminal. So this cable is called USB to RS232 cable socket. So and this is an cable. Okay. So here I was used one cooling fan. Actually the project is SCADA. Supervisory control and the data acquisition system. These are the sensors will continuously get the data onto the environmental conditions. It's called smart building environment. These are the sensors are continuously taking the data and that should be displayed on the LCD. That is happy, and also we are displaying the data onto the PC. So if there is any changes in their conditions, called temperature is above 50 degree, 45 to 50 degree, and the humidity we are giving the 50, and the smoke 200 and above. These are the field we are giving the set point. If the set point will be changes, according to set point will be change, that cooling fan will be cool that room. So it will be comes from the actual room temperatures. So if there is any temperature is increases, then the cooling fan will be on. So I will show the output. So I taken one doob stick. So I am increasing the temperature. Let us see. So I was inserted onto the upper 36, 36, 42, 50. So it's in 50 means 45 and above, that cooling temperature will it will cools. Okay. So 47 means 45 and above. So I'm going for the humidity. Humidity means I have to give with my with my hand or whatever it may be. I kept 100% LRH. You can observe the PC also. You will get the output onto the PC continuously. Normal temperature in the mundu high temperature. Normal temperature, high humidity, so we are given means 50 and above. Normal CO2. So I'm going for the CO2. Better I was used I'm using this one. So you can observe onto the CO2. So CO2 182. It will be on. So actually in this project, if there is any changes, according to the cooling fan will be on. So we can go for the larger number of sensors, lighting sensors and fire sensors. If there is any problem, we will get the data onto the PC. As it is, we will get the data onto the PC, and at the same time we can see the LCD also. So if there is any doubt, let me know to SVS Embedded. Thanking you.